Hello, everyone, and welcome to the August edition of the DeFi Security Summit webinar. Hello, everyone, and welcome to the August edition of the DeFi Security Summit webinar. As a reminder to you all, the deadline for submitting your speaker applications for DeFi Security Summit ends at August 31st, the end of Sunday. So this will be your last chance if you want to speak in Buenos Aires, November 21st. DSS this year will be held during Devconnect. And also, as other exciting news, we'll start announcing some of the speakers that have already been accepted to DSS starting tomorrow. So stay tuned and follow us on Twitter to see them. Unfortunately, due to unforeseen circumstances, Alex couldn't join us today, but we have an excellent host of moderator and panelists that will talk to you about a very interesting topic today about DeFi automation. And our moderator today is one of the more famous security engineers out there, coming from Trail of Bits. It's Niceto.
Well, thanks for the kind word, Jerry. Hello to everyone. Happy and excited to be moderating this panel with a killer lineup with Agustincito and Aditya from Mimic and Brahma. So we'll be discussing automation on DeFi and especially with a security mindset, as this is our credo at DSS. As our first speaker, I will give the lead to Agustincito. I will let you introduce yourself. He's working at Mimic, as I said already, and they are specialized on automation on chain. So I've already had a glimpse at his presentation, and it's pretty interesting. Agustincito, do you want to take the lead?
Yeah, of course. Thank you very much, and thank you for giving me the space here to talk and to present. It's gonna be fun. Can you see, guys, the screen? Is that okay?
Yeah, perfect.
Okay, so today I'm going to talk about scaling Ethereum development with trustless automations. I'm the tech lead at Mimic. So we do automations. We have been doing automation since 2020, 2021. Okay, so basically there's a dilemma that usually automations, it's not usually prioritized. And this we see 90% of the times with our customers and myself. Before working at Mimic, I work at other companies, and we have a lot of repeated processes, but basically they were a waste of time. There were some manual interventions, sometimes like involving a multi-sig, where a lot of people have to sign, see all the configurations, check that everything is okay, and it's usually error prone. So a funny story, basically we were doing some automations for one of our clients, and we started automating some operations on chain for like the whole like all their processes. But we started with a small part of their processes just to see how it was going, because like the client didn't want us to automate everything. But they have one process where they had to send like WETH to some, like every month to another address, and they sent WETH to the WETH address, to the WETH like smart contract. So they couldn't, like, basically they lost all the like the WETH that they were sending and everything. So after that, obviously we started automating every operation they had. Because of this, it's really error prone when you do things manually. Usually also there's a custom script. I've been there as a dev also, where you say, okay, I'm gonna build this custom script to automate something, some smart contract call, something on chain. The problem with these scripts is that sometimes only you know how it works, and like or the senior dev knows how it works and goes through generation to generation, like and it's really hard to maintain. It doesn't have any standards. Everybody does these scripts differently. So this is a great issue. And also when you have to get data off chain, for example, like the price of something, or even on chain, sometimes like the RPCs, they don't work. They go off the tip of the chain, so you are not getting the data, like it's outdated data. So yeah, they're unreliable. And also, if you have to send transactions, you have to store the key in the servers. So maybe sometimes, hopefully, using something like KMS from AWS or other key management systems out there. But hopefully, you use that. But like the reality is that most of these automated process, they have this key store in the server, and basically this is a critical mistake, because if that key gets leaked for some reason, then they can do transactions on your behalf. And we've seen like this a lot of times. So doing automations manually, it's hard, and doing automation on chain, it's hard also. So a little bit of our journey on how we came up with this idea of trustless automation. As I said, we've been doing automations in 2021. And before we did everything on chain, like we code a smart contract for every client. Every smart contract was different and tailored to the client specific needs. And this was great. We could integrate with protocols. We use on-chain oracles, but the problem is that it was really hard to change. So if they ask us to change some configuration on their end, it was really hard to change that. So we started adding customizable configurations. This was like we call the stage 2. So if, for example, they wanted to change if like certain parameters to execute like the automation, for example, if the gas price was below a certain threshold, we should like do a swap, or the price of X token was below something, we can swap them, things like that. So customers could change these configurations, but they were highly coupled to protocols. Again, we deployed one whole like recipe for every client that we have. So we started thinking about like the Lego pieces, where like we created connectors. So basically each connector could talk with different protocols. So let's say a client wants to add a new AMM or a new bridge. It would be easier for us to add them. We just add the connector to like their automation, and they could start using that. And this was great, and we still have this running right now for a lot of different customers. But the problem right now is that they depend a lot on us to deploy the whole automation, to do any change, to add any connectors. So it's really dependent on us, and we think we can do better, and we know we can do better than this. A little bit of the track record, we already processed more than 7 billion in value. Most 30 million transactions, they went through our smart contracts and systems. And we automated 700,000 transactions with almost 100 million simulations to check that all these automations, they were successful. So the idea is that people can create automations without depending on us, or without doing, as I said before, like custom scripts, having the keys on their servers, relying on private data. So, well, this is basically the why. We don't see any robust solution in the space right now, so that's why we started building this, and this is what we call the protocol. So basically what we want to see in this solution, a standardized way of doing these automations. There should be some low-level abstractions, and I think this is critical. Basically, if you want to swap something, or if you want to transfer or just make a call, you don't have to worry. If you want to swap, you don't have to worry about like which AMM to use or where to swap or which API to integrate, if it's 1inch, if it's Velora, if it's Uniswap, you don't care about that. You just want to get the best rate possible. If you want to do a generic call to a smart contract, you shouldn't be handling keys to send them those transactions. If you want to bridge, you shouldn't like know which bridges are available to use. So that's what we mean with this low-level abstraction. There has to be like trustless data sources and that can be verified also. The execution has to be decentralized. This is important. We don't want to rely just in one server that if it fails for any number of reasons, your execution or your automation fails. It has to have proper access control. It should be that you can enforce everything on chain if you want to get more secure properties. And also there should be great monitoring tools. So a little bit of this like protocol that I've been telling you, and the idea is that anyone can automate things on chain using this protocol. There are 3 layers, what we call the planning layer. So basically in here, anyone can implement their own task. The task, right now we have a library to write assembly script that compiles into WASM. So in here, like the idea is that in the future, we can create a Rust library, Python, or the community can create those that they compile into WASM. This get picked up by, like you publish the task to the registry, and then it gets picked by our network of relayers. The relayers then compete to run this task based on the triggers that you decide. They can be like time-based, for example, a cron job every day, every week, whatever you like, or it can be based on like an event on the chain. So if, some contract emits some event, you can trigger the automation. It could be basically on the price change of an asset also, or the balance of an account. So if a balance drops through a certain threshold, then you can execute, for example, a task to refill the balance of that account. So the relayers, basically, they run this task that it's compiled in WASM. In the task, you can access different queries to different oracles. So you can get the price of an asset, you can check balances on the chain, you can check whatever you want, basically an RPC call. And in there, the task, what they create, basically, they are intents. So an intent to swap, an intent maybe to like do a cross-chain swap, an intent to do a generic call, do a transfer, all these kinds of intents that you can do. So basically the oracles, again, it's a network of oracles. It is to have many oracles that they also, and you can get basically the response for different oracles and apply what you want to the result. So if you want to do, for example, for a price, the median of that price that you get from different oracles, you can do that. If you want to do the mean, the max, the average, whatever you want on that price. And this is all really easy using like the library and the tools we have built through the protocol. So the idea is that for developers, you don't have to create accounts on different basically pricing providers or RPCs. It's very easy out of the box. And then you create the intents, basically specifying what you want. So you don't have to know about like what protocols are you using. You just create the intents, and this is where it goes to the execution layer. In the execution layer, basically, before it gets to on-chain, we also have like a network of validators where like the relayer, they create the intents, they run the task, but then also the validators, they run the task to verify that everything that runs, it's okay. and it's what the user expected to be. So these validators, basically, it's just really easy because the validators, they don't have to query oracles, they don't have to know the triggers. It's basically verifying, for example, if it's a time-based trigger, they verify that, okay, it's the time that the user said it wants that task to be executed. The task runs and generates these intents. With these Oracle responses, it generates this intent. So the validators, basically, they validate everything that the relayer does. And once we get enough, basically, verifications from these validators, we move the intents to the next step, that it's basically auction those intents to the solvers. We have a network of solvers again, and these solvers, they compete to get the user the best price for those intents. So if it's a swap, it means that you have less slippage. They give you more amount out for your tokens. If it's a transfer, it means that the fee that they take you from executing that transaction, it's less than the other one. So basically, the solvers compete to get you the best value for your intent, and then they can execute those intents. And this is where we go to the security layer. I think most people will be interested in that in this event. So basically, we have a settler smart contract where it checks that all the balances, everything that the intent says, it's being fulfilled by the solver. So we have that enforced on chain. And also, this is very important, we have safeguards that you can build, that they are basically on-chain rules that you can put on your tasks. That basically it says, okay, you cannot swap more than X amount, or you cannot you can only call this function, for example, to if you, I don't know, if I'm doing a task to get assets from my account and invest them in Aave. Okay, only you can call Aave and this specific selector of this function to invest in Aave with this amount. You cannot withdraw on my name. You cannot do anything other than just investing in Aave. And this is obviously everything it's enforced on chain with these safeguards that we have. So yeah, and that basically the intent gets executed, the solver checks everything, it checks the safeguards that you can put, and this is how basically you can code things in TypeScript, in Rust, in whatever you want, and just call like a function to transfer, to swap, or to do whatever you want, and then it gets translated on chain in a secure way. So yeah, that's basically the gist of the protocol. Our goal is, again, to standardize the way we automate things in the industry, to have a great developer UX, so that you can use these curated data sources and a lot of things that they come out of the box if you use basically our protocol, that, as we have seen, they are hard to do on their own. So yeah, that's it. If you want to learn more, please visit mimic.fi. You can go to the docs or to the white paper. And I'm also happy always to chat. So you can look for me in Twitter or in Telegram and ask me questions. I really enjoy doing what I'm doing. So I'm always available to chat and to discuss things. So yeah, that's it. Thank you guys for giving me the space to talk about this. And if there are some questions, please let me know.
Thanks a lot. That was very interesting. We don't have any question yet, but on my side, I may have one or two. If people want to try out and use Mimic protocol, how could they do it right now?
So you can basically Mimic protocol. It's not like live right now for production use cases. So you can go to protocol.mimic.fi and you can start like maybe in there you can see all your tasks and everything, but where you should start basically it's in the docs. So if you go at docs.mimics.5, you should see how to get started. There's some examples. We have a repo with examples there. So you can also, I think it's in mimic.5, but you can subscribe to our newsletter to get updates on when it's going to be production ready and live, so you can try use it for live production use cases.
Okay,
but yeah,
great.
just go to docs.mimic.5 and we have a great starter example there.
Okay, great. And I have another question, which was you presented the 3 layers protocol infrastructure. Which part of these layers were on chain and which one are off chain?
That's a great question. Yeah. So basically the security layer, that's all on chain, and that's where you get like the strongest guarantees. That's why we have like the settler, the safeguards and everything. The rest, basically the planning and the execution layer, they happen off chain. So we validate a lot we play a lot with signatures and like permissions that you can give, but everything that it's on chain, it's in the security layer. This is where we have strong guarantees that what you say, it's what it's going to happen, basically.
And part of the layers are the solvers and the relayers. You said, if I remember correctly, that you have a network of solver. How are you whitelisting them? Who are they, basically? Which type of actor are they?
Okay, perfect. Yeah, of course. So like right now, again, it's in super, let's say alpha. So we don't have like a network. The idea is to have like a network of a lot of solvers, relayers, validators, and everything. Basically, they have to basically stake to be able to be part of like relayers, solvers, and validators. And if you want to stake, depending on like which actor you're gonna be, at the stake it's different, but you have to stake. And then you can be part of the network. And basically, if you misbehave,
Mimic token, I guess. Do you have your own token?
No, it can be ETH. We haven't decided the exact details yet, but yeah, it could be a lot of it could be ETH, it could be whatever we decide yet. But yeah, that's basically the idea.
Okay, thanks. We get one question in the chat. Do you have access to the chat, Agustincito, or not?
I don't think so, no.
Okay, I will read it, no worry. You mentioned that you can verify that what was expected to happen actually happens. I think it's part of the security layer. Can you also prevent unexpected or malicious actions from occurring? For instance, a hidden malicious approval for a specific token.
I'm not sure what they mean, but like you can in the safeguard specify like everything that you want to the protocol to do. So if you say, okay, like I just only can invest in Aave, then nobody can call from the automation like, hey, just approve this token to be moved, for example. And also we check
I can imagine a scenario of, for example, the UI of a user would be hacked, for example. And so you know for sure that certain actions should be happening. And this might be one of them, a malicious approval for a specific token. And in that case, you could be kind of blacklisting this type of actions.
Yes, or things that you can do. Basically, it's, for example, one thing that you could do, it's have like a security component with an automation where basically you say, okay, I'm only going to approve these tokens, let's say, and if you, whatever reason you approve another token, this gets emitted maybe an event on chain. You can listen to that event and say, okay, just like you can give our settler permissions to basically just not approve, like disapprove those tokens. So the automation would basically be dispatched, and we would like roll back that approval. That's something that you can do.
Okay, thanks. Please let me know in the chat
course.
if the answer wasn't what you were expecting. And I may have one last question. If I remember correctly, you can trigger some action from an event incoming on chain. Can you do that also for an off-chain event? Like, I don't know, you receive a Telegram notification or something that would be triggering something on chain?
So right now, no, there's might be ways to go around this, but the problem is that we don't have a way to verify that in the network. Like the validators wouldn't have a way, but if you like trust one of the actors, you as a user say, okay, I trust this actor, let's say, or this Telegram, then there's ways to do it. And we maybe wouldn't check that, but yeah, that like right now, that's why we're going for on-chain events and things that can be verified. So that like, because if not, we don't have like the validators cannot verify that indeed happened. So yeah.
Sure. Okay. Thanks a lot. I will definitely be following the development of Mimic in the foreseeable future. AD1, which is with us, the second speaker of today's webinar, lead smart contract engineer at Brahma. So I think Brahma is a pretty well-known brand in our space. Just for those who don't know Brahma already, they pioneered the on-chain solution for transaction and volume. And so Aditya, if you want to take the mic, we are all ears for your presentation.
Thanks, Nisado. Let me just quickly share my screen. Okay, let me know if you guys can see it.
Yeah, perfect. Thanks.
Perfect. Hey guys, I'm Aditya. I lead the on-chain solutions at Brahma. We have been working on this problem for about 4 years now, where the core problem is how to automate transactions on chain, and by automating, make the life a little bit more easier for the user. So provide them a Web2 kind of experience where they just set it and forget it. And this goes into why would you need automation if you can just click your wallet on MetaMask. A lot of these transactions that automations might want to do are MEV-driven or machine-driven transactions. So it could be as simple as checking an event which got logged on the blockchain, or it could be a series of very complicated FNLs and a lot of conditions that match together to make sure, okay, now is a good time to make a transaction. You can do a lot of MEV, you can handle liquidations, you can also do a lot of yield optimizations, which is if you have capital allocated in one vault and let's say the other vault or other source is giving you a better yield, you would like to reallocate the capital to that vault in an automated way. And then there are some transactions which are not easy to automate, which are more like user events. So something like, let's say I have a user who wants to pay for a coffee in a cafe. And as the systems builder, I can never predict when that transaction is going to happen, when the user wants to pay for that coffee. So that is the kind of means that we want to provide, where the users can execute transactions at will, and we can automate transactions as well. So DCAs and TVOPs I kind of glanced over, but they're pretty much the same thing, which user sets a DCA, dollar cost average. I want to buy X amount of this asset every year, every day, every month, whatever they want to do. And doing it on-chain is very hard. If I have to do it personally, I would have to set up a timer, set up an alarm clock, and go to my preferred DEX, place that trade, and make sure I do it every day, every week, whatever my priority is. So this is something that users should be able to automate pretty easily, but currently not a lot of solutions available. So let's see at what are the requirements to automate an on-chain transaction. And this discussion is very specific to EVM, but will generally apply to broadly to most of the blockchains out there. So you have the first topic is private key management. If you're working on EVM, if you're sending transactions, if you're doing anything at all with EVM, you have to have a private key, right? That's your account. That's how you identify on chain that, hey, this is me. I want to send this transaction. And there are a couple of solutions available, as Augustine also mentioned. Like you have the AWS KMS, which is a good way to store secrets. You have the Key Vault, you have the HashiCorp Vault. All of these solutions are not built for key management per se. They are built for secrets management. So what that means is, let's say I was using an RPC, and the RPC has an API key, which is a secret. I can store it on AWS or Azure wherever I want to. I can store it on HashiCorp. And during execution, my code or my backend, any service can fetch it in the runtime from the service. And basically, then the service has access to that secret. In this case, let's say I had an Alchemy key. The Alchemy key will be present on my service, and my service will be able to use it to do anything, anything that it wants, including let's go for the case of private keys. If we store private keys on AWS, Azure, you can easily get them into your service, and then you can start signing transactions. But then how do you make sure your service is not signing the wrong kind of transactions? So how do you know a service doesn't go rogue, especially if it's a large organization and you have a lot of people shipping? So a way we devised a solution for this is we built a HashiCorp plugin specifically for Ethereum key management. What it does is it acts as a plugin on top of the HashiCorp Vault structure, which makes key management very simple. So now if a service needs to use a key, it does not have to fetch the key. It simply sends a message to the HashiCorp Vault saying, hey, I want to send this transaction, and I would like a signature for this. And if the HashiCorp Vault says, yes, okay, you're good to go, a HashiCorp Vault will itself generate the signature in its secure environment, and then just present the signature back to the service. So this makes sure you're not leaking keys into your services. And obviously, this makes for a much better security model in terms of managing your assets and secrets. That's one of the innovations that we did over the last 4 years, because we had this problem coming up repeatedly. And the other part of the automation stack that you need is RPC. Now, as Insedo again said, RPCs can be very stale. RPCs can go slow. They can be out of sync, sometimes by even multiple blocks, depends on the chain. So unfortunately, we haven't found the best solution for that. But right now, the current solution that works for us is just having an on-prem RPC. So we can make sure the uptime is good, and yeah, we can monitor for any kind of instability that happens. Moving to the next one. So let's say we had this stack. Let's say we set up our key pairs, we set up our RPC, we are ready to send transactions. How do we scale it? We use a service, we build a backend. Let me go back to the slide. So we have a backend. The backend is going to get a signature from the HashiCorp Vault. Good to go. It's going to publish the transaction and the signature using the RPC on the network, and go. Good. Your transaction is done. And this could be for whatever intent or trigger that you might have. Maybe a user wanted to pay for his coffee. You got the signal that he wants to pay. Immediately get a signature, publish the transaction. Boom. But what happens when you have to scale it to, let's say, multiple transactions happening per second? So looking at this case, you have, let's say you have one key pair, like let's say my wallet ABCD, 0xABCD, and I'm just continuously fetching signatures. My service is running on a loop. Whenever it gets a new transaction, it fetches the latest signature for that particular transaction, publishes it on chain. Now, the issue here is a lot of the times what we observed was RPCs would give us stale data, or RPCs would give us unconfirmed data, which they are purely in the right to do so. So transaction one went through. It's still sitting in the mempool. It's waiting to be confirmed. Meanwhile, we wanted to sign a second transaction. The RPC does not know that there's a transaction already waiting, so it's going to give us the old nonce. And when we try to sign the new transaction with the same nonce, the nonce will conflict, and our transactions won't go through. So that was again a big challenge that we have. And I will address this challenge in multiple ways. But the first step, the first logical step is have multiple key pairs, right? Like have like 10, 15, whatever you need, depending on your volume. Have those in a round robin fashion, maybe an array, and just iterate over them whenever you have a mutex lock on them saying, okay, this KPI is busy. Let's go with the next one. Let's go with the next one. Now, the issue that we faced with this is, remember the old key pair that we had, the one key pair? This used to identify us that, hey, we are XYZ, we have Brahma, we have this authority on chain to execute this transaction. Excuse me, guys. So executing transaction could be in maybe we have approvals from the user, maybe we have some delegations, maybe we have some assets that we want to approve. So whatever we want to do, this is a key pair which has the authority or the assets to do so. Now when we move to a multi-round robin fashion, it's very difficult to hold assets across multiple keys, hold delegations across multiple keys. It kind of fragments your whole system, and it's not viable in a production environment. So then how do we solve this? So we put an execution contract in the middle, which gets all the delegation powers. So as you can see, we have 1 to n key pairs. We can have like 10, 15, 20, 30, how many ever key pairs we want, who have authority to execute or send a transaction to our execution contract. So this execution contract has all the power. It has all the delegation. For example, if my user wants to pay for his copy, he will delegate his assets to my execution contract, not to my key pair. This allows me to have a better secret management experience. I can rotate key pairs. I can switch key pairs. This execution contract is currently a Gnosis multisig safe for us. And we ended up developing custom plugins, Gnosis safe plugins that can allow us to manage our key pairs. And these key pairs can set any number of transactions, right? So you have key pair 1 sending nonce 1, key pair 2 sending nonce 1, whatever. At the end of the day, it's the nonce checked at the key pair side, but all of these key pairs can execute in parallel to the execution contract, which unlocks a huge scale for us to the destination contract, whichever you want. An additional feature that I kind of glossed over is looping multi-calls. So because as we know in Ethereum right now, I mean, it's a bit outdated, but with 7702 is possible. But without that, you have your key pair, which can only execute a single transaction. So it can only either, let's say you want to do a swap, right? You would have to do one approve and then one swap, which is not very ideal. And with the execution contract, you can batch all of your calls together in one multi-call and then send that multi-call to whatever destinations you want. So one call goes to my USDC contract for approving to some swap router. Second call goes to the swap router to actually swapping the tokens and sending it back to wherever the user needs. Now, this solution worked pretty good for us, but we were still not satisfied with the amount of security that we received from it. So things could still go wrong, especially when the services are not acting the way they should. So how we added this extra layer of security is we expected user to provide the automation delegation to the execution contract. And let's say you want to automate a user's transactions, right? Let's say I have MetaMask. Now MetaMask has $1,000 and I want to spend my $1,000. Let's say MetaMask gives me a card, like Visa credit card, and I want to spend it and my funds are in my wallet. How does MetaMask ensure they can take my funds out of the wallet? They obviously have to do some kind of they need some kind of an authorization, right? Either they have my private key, which they're storing somewhere, which is not the ideal solution. That's why I wrote users should never be expected to provide the proprietary keys. What here user does is user gives a delegation, like an approval of their on-chain assets or on-chain possession. This could be your USDC token, which you're given an approval for. This could also be a USDC spending power. For example, you lent your money into an Aave. You want some yield on it. You don't want your assets sitting idle, right? But you could still approve those assets to us, and we could borrow based on that behalf. So if you lent WBTC, you don't want to spend in WBTC, but you still want that WBTC exposure. You have lent your assets in WBTC, and we can just simply, borrow X amount of USDC from your collateral available on Aave. And those are the kind of automations that we really wanted to achieve with this solution, especially because stablecoin spending is getting a bit old. And we do want to get users to that centralized bank experience, right? Where your money is still getting yield. It's not sitting empty. So automating on users' behalf, as I told you, we were still not very happy with the level of security that we had achieved. We were very confident about the secret storing, but there was still an ambiguity on what kind of transactions could be executed on users' assets. Now, we cannot execute on user's wallet, but that's where we came up with the idea that okay, let's give user the programmable wallet itself. So we have a key pair setup here. We have an execution contract, and here we replace user with a smart contract wallet. In this case, it can be a Gnosis multisig. It can be the base smart wallet. It can be any wallet that works with 4373 or the currently in our case, we use the safe plugin methods to add composability to this wallet. So we added transaction guards, which are available on Safe Multisig, which make sure they do a pre-check and post-check after transaction. So let's say I'm trying to execute a transaction to approve some tokens to Aave. There will be a pre-check transaction where I can scan the bytecode. I can have a look at what type of transaction I'm trying to execute. Post a transaction, I can look at what EVM state changes happened during the transaction. How much did my balance decrease? How much did my approval go down or up? Did my balance increase for a certain token? So using these parameters, we can build on-chain validation to make sure that only things that are supposed to happen on the user's wallet. And at the end of the day, it's a multisig. User can set it up as a one-by-one multisig, so he has full and sole control over that, and they can kick us out of the execution rights at any point in time. There's another artifact of transaction simulation that we wanted to do, which is when we're trying to execute a transaction, we simulate it fully on our backend, make sure that it matches with our policies as well, and provide a signature of sorts to make sure that, okay, yes, we attest this transaction, we are confident behind this, that this is not a malicious transaction. So coming to real world deployments, all the architecture that I explained, how is it currently being used? So we came up with, I think there's a third product in automation. We did AI agents. We did on-chain automations, like DCAing into multiple assets on multiple chains. We are live on 10 chains. And currently our latest product is Swipe.fun, where users can just quickly sign up and get a Visa card issued to them. And they delegate us our positions, how much ever they want. They can have a 6 figures, 7 figures, doesn't matter. They should only delegate how much they're planning to spend, which can be like $1,000, $10,000, whatever they want. And the same infrastructure happens where they tap on the coffee shop POS point of sale. The transaction validation comes with us. Like we get a notification saying, okay, this guy wants to spend his money. We quickly check whether this guy has enough money in his wallet to actually solve the transaction. So that could be any kind of DeFi position he has. As long as we are able to solve it into USDC, we will take that to the USDC and we will settle Visa. This all happens in about 800 milliseconds. And for the user, it's very simple. You just go tap your Apple Pay on any point of sale and it works like magic. So anyone who's interested, do try it out. I think that's it for me. Do you guys have any questions? By the way, I'm always available on these links to chat, talk. Happy to be here.
Thanks a lot, Eddie. I definitely recommend everyone to try out Swipe.fun. At least the website is really, really cool, to be honest. Just went there before this webinar, was really impressed. I don't think we have any question right now. I may have one, maybe for the both of you. You, if I'm not mistaken, are both targeting mainnet, Ethereum mainnet. Do you have any plan on deploying to other blockchains? And if not, why?
On our side, we're not only targeting Ethereum mainnet, but like Optimism Base, Polygon,
Okay.
a lot of chains. So yeah, the idea is to go in as many chains that we can. And also we have like these low-level abstractions where like you can do like a cross-chain swap or a bridge to other chains. So yeah, the idea is to embrace
EVM-based chains, right?
Yes, we're working towards having Solana also, okay. Another non-EVM compatible, but for now, yes, it's EVM.
Okay.
I think it's curious because I think we name things differently, but they are mostly the same when you look at the roles. Yes. Like the settler, our settler is your execution contract. We have the same issue when like executing on behalf of user like generic calls. They have to be also smart wallets. We cannot just do a generic call to an EOA. So yeah, it's good and also the same problem. So I think we're both on the right track. But yeah.
Yeah, one other issue I noticed with the 7702 implementation is that a lot of wallets have locked it to their own implementation. So I cannot provide my own 7702 implementation. If user is using MetaMask, they will be locked to how MetaMask wants to implement it.
And have you found a way to bypass this restriction by 7702?
Not really. Right now, as Augustine said, we are using smart contract wallets to
Okay.
bypass the issue. But at the core level, the wallet or the key holder is the wallet provider, which is MetaMask, and they hold all the power.
Yeah, logic. I actually have $1 million question given the recent news, at least for the last few years. What about AI, guys? Have you implemented it in your protocol? Have you tried it? Have you thought about it? I can't think of any team at Trelobit that is not working hard on it. So I guess you should be too at Brahma and Munich, right?
We did experiment with a lot of LLMs, and
Okay.
with the correct set of permissions, we did give them the, let's say, the capability and the context to actually execute and automate transactions for the user. So we do still have a couple of agents live, and I'll be happy to drop a link in the chat.
Okay. And what were the results of your first experiment with basically autonomous agent managing your users' funds?
There's a lot of safeguards to be implemented because AIs or LLMs are such a thing which you cannot really moderate the input that the user can provide. So you have to account for a lot of different types of inputs and what the agent might try to do from that input. And you have to restrict the agent into certain boundaries, certain safe boundaries which are beneficial for both the user and the protocol.
Are you doing that
So that's
through the execution contract?
Both. So we have to set up the LLM also in such a way that it discards 90% of the invalid inputs or invalid requests that the user might provide. And setting up execution policies, as we discussed in the last slide, making sure that you cannot spend more than X amount of money. And your tokens are only going to all the whitelisted addresses that we have decided for you, which might be swap routers, which might be yield products, etc. So you shouldn't be able to send tokens to random addresses.
Thanks.
So we have like a similar approach where we think it's not like AI, it's gonna be doing everything for the user because again, that there's a problem of the risk and the permissions that you want to give the AI. So in Mimic, you can do like small like tasks that do certain things, and then like you can change the inputs and the parameters of those tasks. So we don't see like the AI use like doing the coding of the tasks themselves, but mostly and executing them, but mostly like you said at DeFi, like defined task that the AI can use, and the AI will pick the best one and fill the parameters with all the safeguards to use them so that like it has like a little bit of like guardrails so that you don't let the AI do anything, but just these predefined tasks that anyone can code.
Okay, yeah, makes sense. Seems sound definitely safer than letting an AI go rogue with any user's funds, to be honest. Okay, guys, thank you very much for this answer. We don't have yet any question in the chat. Yuri, sorry, maybe do you have one?
No, not at the moment, but I've learned a lot.
Yeah,
Thank
definitely.
you guys for an interesting webinar. We can see that making things simple and easy for the user is actually a lot of work behind the scenes. Usually the case, right?
Keeping it secure makes it even harder.
Yes.
That's true. If we could only forget that part, but we don't. And I'm reminding you again, people in the audience, if you have anything interesting about security in Web3, and you want to speak in DeFi Security Summit in November 2021 in Buenos Aires, Argentina, the deadline for speaker applications is August 31st, which is Sunday. So that's going to be your last chance. Don't miss it. We want to hear your good ideas, your good insights. Thank you again, Aditya, Agustincito, and Icedo for a very interesting webinar. I hope you enjoy, and I hope the audience have learned new things.
Thanks a
Thank
lot.
you for yeah, thank
Thank
you
you
for
for
the time.
inviting me.
Yeah.
Bye-bye.
Bye, Gael. See you in Buenos Aires.
See
See
you.
you in Buenos Aires.